Alright, I just realized that I completely forgot one topic for implicit differentiation that shows up on a lot of free response questions. Horizontal and vertical tangents, which you already know, but in implicit there's a little extra algebraic step. So horizontal tangents happen when your derivative is 0, and vertical tangents happen when your derivative is undefined. And this is actually really easy to do when your derivative happens to be a fraction, and most implicit differentiation problems, your derivatives are fractions. So I'm just going to take one of the free response questions. I don't remember what number this is in your packet. I actually can pull it up. It is number 2 in your packet. Okay, so I am going to skip over this one here, just because that was in the video. Find all points whose x-coordinate is 1. You can do that writing an equation of a tangent line. You should be able to do that because they're telling you that this is the slope. And even if you don't get part A right, you can still get part B, and you can still get part C because they're giving you the derivative. So that means for part A, to get your points, you have to show your steps. Part C, it says find the x-coordinate of each point on the curve where the tangent line is vertical. So that's a vertical tangent. Vertical tangents happen when the derivative is undefined. This derivative would be undefined if the denominator is 0. So that's the denominator set equal to 0. If it was a horizontal tangent, then I would set the numerator equal to 0. In this case, there's 2 variables and only 1 equation, so there is going to be an issue. I'm going to solve for my y by moving the x cubed to the right side and then dividing by the 2x. So I get that y is equal to 1/2 x squared. And that doesn't really help me because I need to find the x coordinate. So I need another equation. So what you should understand is this tells you that the derivative is undefined, but the only way that you can have an x coordinate with a tangent line is if that x coordinate is a coordinate on the physical curve. It has to be on the curve. So if you want it on the curve, that means we can use the equation that is given, and the slope has to satisfy that equation because the slope has to be found at a point that is on the curve. So now what I'm going to do is the system of equations. I'm going to substitute in my y, which is 1/2 x squared, whole thing squared, minus x cubed, 1/2 x squared equals 6. So in this case, I think I end up with x times 1/4 x to the 4th power minus 1/2 x to the 5th power equals 6. So we end up with 1/4 x to the 5th minus 1/2 x to the 5th equals 6. So I get, looks like negative 1/4 x to the 5th equals 6. Hopefully I didn't make a mistake here. So the x to the 5th is equal to negative 24. I believe this is correct. X is equal to negative 24 to the 1/5 power, which is okay because it's an odd root. So, or the 5th root of negative 24. And they only asked me for the x coordinate, so that would be enough. If they asked me for the point, then I'd have to go back, substitute back into either this guy or the original. I would obviously pick this one to substitute into to get the y coordinate, and then the last little piece, if they ask you for the coordinate, you'd have to check your solution. What do I mean by checking? When you get your point, you'd actually have to make sure it satisfies this equation, meaning it's really on the curve. So that was the little addition I needed to do. So remember, this was where the tangent line was vertical. The only difference, and I wouldn't do it with this problem, but if I asked you where the tangent line is horizontal, then I would have to set the numerator equal to 0, because that's the only way a fraction can be 0.